so maybe I could just catch up on that.
With what?
The best way.
For this
It'll make me
class?
go through everything again. Yeah. The like non-graded stuff.
Oh.
Yeah.
You weren't doing that?
Nah.
I've been doing it slowly because I know I couldn't do it all at once.
This stuff was pretty complicated to me because I missed class, so I had to look this up. There's a pretty nice YouTube channel I found for discrete math, though, that made everything pretty easy.
What was it?
It was... Oh, 1 second.
Or you could link it later if you want in the Discord.
Yeah, let me find it now. I'll definitely forget.
Did he just like evaporate?
Yes.
You gotta do the proofs now. Ooh. Prove Mr. Forcey left the classroom. Do it.
I mean,
By using the contrapositive.
contrapositive of what?
Mr. Forcey leaving the classroom. That's not even an implication, I know.
Well, not
Just play with it, dude.
because if you were using the contrapositive,
Don't kill the skit, dude. Just continue it.
If you were using the contrapositive,
Oh my god, dude.
it would still be wrong. Because the contrapositive is not equivocal.
Dude, you're not going to Ace Improv.
I know. I take everything hyper literally.
You came here and you majored in improv comedy,
No, I didn't.
Thompson.
but now you're trying to be all logical.
Limit. Fesley. Hey, there you go.
See, I already almost forgot what I was doing.
It's that easy.
Here. He wants this one back. Later, though.
I don't know. I kind of regret uploading those YouTube videos to the Discord because now everyone knows me as the dude who takes video lectures.
Oh, no.
You're the dude.
Yeah.
All right.
Oh, I'm probably blocking you right now.
Me too.
Yeah.
Okay, so.
What are these called again? Oh, for all.
Probably end up doing mostly just review today. So here's a answer to a question I got a couple of times. The online review that I put up just has some extra questions. Like I didn't have time to put everything on it. And so the quizzes were the main ones. Oh no, it's on the I sent an email with a link to it. It's to the regular my personal course homepage, and if you click that link, it goes down the page. It has a hashtag to it. So yeah, I sent that email over the weekend, so you have to look back through your emails for details. So I guess I could go ahead and do some of the problems on here. I'll leave a few of them for you to try if you haven't had a chance yet, because it's supposed to be a good opportunity for a self-test. But, and then I'll go do some more problems from the quizzes, or similar to the ones on the quizzes that aren't on the review, but you still need to know them because they're on the quizzes. And if I take away the opportunity for you to self-test it, I think it's still okay, because there's so much on this test, and there's so much else going on with all the other classes and everything, that if you like wait a couple hours and then do it again without looking, it'll still be a pretty good self-test. It's not, it doesn't hurt it if you've seen the answer, you know? So, like here's the first one that I put on there was a truth table to fill out. And just with P and Q. And I basically did make you show the work on
Did you
this
find
one. I made you do a
I'll
bunch
put it in
of
the Discord.
small truth tables for some basic operations before getting to the big one. And then it asks whether that one's a tautology or contradiction or neither. So here's the given values. And the first one is just not Q, so I just switch them all. True to false, false to true. P implies Q is a good review of that. And that's going to be true except for that one time when you start with true and end with false. True implies false is false. And then there's a P or not Q. So I look at the P's and the not Q's, and then it's going to be true of either of them. So you get true and a true from those. That one's false because they're both false. Yeah, that one's true because it's not Q. And finally, putting those together with an and is the last line. So that's only true for the first one and the last one. Is it only true when you have both true? So this one turned out to be neither. To the question, is it a tautology or a contradiction? Nope, it's not either of those. The number 2 is a little different. So I put the truth table on there just to give you a warm up for it, but I think on the test I'll have some questions like number 2 here. It lets you do all the same work, but just for one given set of values for P and Q, or more, P, Q, R. And that means you don't have to fill out the whole table, which takes a lot of time. You won't be able to tell me whether it's a contradiction or tautology, but it just says given that P is equal to false, Q is equal to true, and then it says to evaluate the statement. So P implies not Q, parentheses, implies Q. So it's like doing a truth table, but you know that you're in a row, just one row where P is equal to false and Q is equal to true. So you could draw a truth table for it if you wanted to and just fill out one row. Or you can, I'll leave some space on there. You can do some scratch work underneath it, however much you want. You don't really need to show work on this one if you can just do it in your head. But I'll show some work. So if you have false and not Q is also false, since Q is true, then false implies false is true. But then I have Q is true, so I put true there. So here I've got true implies true, that's true. So the whole thing is true. I guess it's only, I shouldn't use that symbol really, it wouldn't matter. But the answer is true, since I was given that P is false and Q is true. That's okay if you're given that. Anyway. So the next one had P and Q double implication. Oh, we haven't done the double implication very recently, so good review. Not P, parenthesis, parenthesis, or Q. Same values. P equals false, Q equals true. Okay, so what? The P is false, and that has an and. But I don't know what the or there will be. last Q though, that's a true. Oh, so you could actually answer that the whole thing is true right away. Let me go through it because you don't always get the luxury of figuring it out like that. But there is a shortcut here. Since it's attached with or to a true, anything or true is going to be true. So kind of already know it's going to be true. So let's work out what the inside is, especially since then I might make you do it with the opposite values, so you wouldn't be able to do it with that. Let's say, so Q is true, not P is true. Oh, so that's also true. Remember the double implication is true whenever they match. If you have false, false, then false implies false is true, and false implies false is true. When they mismatch, then one of the two arrows looks like this one, and you get a false. It's basically shorthand for implies this way and implies this way. But so true implies true works. You can do that, read that both directions, and it's true either way. Then I've got P and true all together. That would be false, since P was false. But like I said, now I have false or true. So put it together with that, you get true. Yeah, if you saw that last Q on there and said, oh, it's true, so the whole thing has to be true, and you just answered it, then that would be fine. Might be nice to write a little note or something with it to let me know that that's how you figured it out. But I'll probably put one on there that you have to work on it, though. I like to make it at least one that you have a shortcut to as well. Any question? Somebody that looked like they were going to ask me something, and I kept going. Good? Oh, so then the next thing I did here was a little different. It says, repeat the above problems with the alternate given information that given Q implies P is equal to false. So, whenever that is a given, then you know what Q and P are. The only time that you get a false out of that arrow is in this row again. So this is a good review of when is the implication false. It's when you start with true, end with false. So if I have Q implies P is false, then I know Q is true, P is false. That's the only way you can get a false implication. All the other implications are true. So if I tell you what the implication is, as in true or false, then you know what the two parts are. But I made a mistake when I wrote this thing, because I meant for it to turn out differently. But that's exactly the same one as I already gave you. So you get exactly the same answers as before. You know, I get that answer and that answer. It's the same false and true that I already gave. So let's do it the other way. For an extra additional question, not on there, but it's also good. Extra question. Let's just switch them around, just to see what you get. Given, so I already did Q equals true and P equals false both times. So given Q equals false and P equals true. Works the same problem. Just to see. Can't remember. One of them might be turn out to have the same answer. So do P implies not Q implies Q. Okay, so now it's true implies true. That's true. But implies false, so that's false. So that whole thing will be false. If you do that problem. I bet this one turns out false also. I have to work it though. So the next one, let's copy that, was P and Q double, not P or Q. All right, so if Q is false and P is true. So false double and not P. False. Right? Start out true. It's true. But so we have false if and only if false. That's also true. Since whenever they match, false implies false and false implies false. Both give you true, so it's true. The only time that you get false there is if you have a true on one side and a false on the other, or the reverse, false on one side, true on the other. And P is true, so you get true and true, which is true, right? Or Q is false, but you get true or false. So that's true again. This time you get true. Get true either way on that one. I didn't try the ones where you have true true or false false. That could be different also. But there's a fine selection of them. Any questions on that? So just in case, this was a totally over here. This was a separate question than was on the review. Also perfectly good. You could make up your own and do these, but then you don't have a key to check them with. Any combination is fine. You just have to know what to do with them. So let me see. They have then some questions, sentence questions. Well, the next one, number 3, has symbols. Lots of symbols in it. Sometimes those are easier to work with than English language.
Oh, I do have a question actually.
Yeah, question.
What would the negation of a biconditional statement be?
Oh, so you can work that out, the negation of if and only if or biconditional, pretty straightforwardly, but we didn't memorize a special way to do it.
Yeah, I was wondering if it's the same thing as like De Morgan's law with the implication.
It is, because if you have P if and only if Q, that's the same thing as P implies Q and Q implies P. Oops. So we did do that. And then you would know how to negate that, because you can negate it with De Morgan's law and do negation on both of those little implications. So we didn't memorize a way to negate P if and only if Q, which probably means I won't make you do that on the test either, because it would require an extra step that we haven't seen. Well, now you have, but I didn't show it for the other class, so it would throw people off. You'd be like, oh, how are you supposed to negate that? And the way to do it would be to expand it first and then negate the rest of that, which you know how to negate all the pieces of, no problem. Yeah, so if there's a negation problem, it won't have the if and only if in it. So you don't have to worry about it too much. Now you know how to do it, but the other class I didn't mention, so I could tell them tomorrow. But yeah, anyway, that's it's a bit of a headache, I think. I'll leave the double implication just to the problems where you have to figure out whether it's true or false. So this one has, so all these negation problems, they don't have double implications. They have all right, so this is number 3. I won't do all of these. Maybe I'll leave some for you to try on your own. The answers are online. X element of S and X less than or equal to 5 implies X greater than 2 or X equals -10. So that's the original. And then it says things like find the converse. Converse is too easy. You don't have to do anything except switch the order. So there's no negating at all in the converse. The converse, if the original is P implies Q, the converse is just Q implies P. So it'll just be the whole thing. X greater than 2 or X equal -10, but the order switched. X element of S and X less than or equal to 5. So the contrapositive is more interesting. Contrapositive has the negating and the switching, so not Q implies not P. So now I'll switch the order from the original and also negate them, which I'll have to use De Morgan's laws for that. So Q is over here. Let's see. Put a little note underneath it. That's all Q, whole thing, and all P. So not Q would be X less than or equal to 2 and X not equal to -10. So you have to change the direction of everything there. The greater than turned into less than or equal to, and the old or turned into an and then you just put a slash through it equals to negate equals. And then implies and not P. So X not an element of S or X greater than 5. Yeah, for the element symbol, that little epsilon means in the set. The negation, we haven't written that in a while. I wrote it in the notes way back, but it's pretty easy. You just put a slash through it. You could also say X is in the complement of the set S, but you'd have to use words for that or something. So I went with just the slash through it is all you need. So there's a bunch of things for me to check on here. You have to do like 6 or 7 things. You have to change that, change that, change that. The order has to be correct, so the arrow has to be pointing the right way. And then that you change that. There's 7 different things to do there, which I could make it all worth 1 point and make it a 7-point question or something. Some of that might end up being double counting, so it might be worth a little less than 7 points. Just so you know, that's possible. Then it has the inverse and the negation. I want to do the negation anyways. That's good review for that. Like I said, you can go do these on your own again without looking at the answers, and you'll be probably just as good as if you did them without ever seeing them, because it's so, you have to think through it every time. Can't really memorize answers. So P and not Q is the negation. Keep P, change the arrow to and, not on the Q only. So that means I keep P the way it was, x element of S, and x less than or equal to 5. And then not the P, not the Q again. So again, it'll make x less than or equal to 2, and x not equal to negative 10. Checking the answers that I put online. I think I put the words and or on the when I typed it. So either is okay. I'll probably use the symbols more since I've been doing that in class more. But if you switch it to the word means the same thing, I won't take off for that. You can use the word and or the word or the symbol. Any question there? Yeah.
So for the contrapositive, did you take the contrapositive of the original or
Yeah.
the converse?
Yeah, it was the contrapositive of the original. That's what it was. I'll be clear about that. And they're all of the original. Yeah. Right. So. Yeah, that's how I'll do it on the test too. I don't want to get into the weird question where I would say, take the contrapositive of the converse of the original or something. That'd be too confusing. So whenever I say find the contrapositive or find the converse or whatever, it'll always be of the original in the statement. Helps to also not have multiple questions under one original. I like to do that for review. It makes it faster. I can write the review real quick, but for the test, I'll probably have separate questions for most of them, so you don't have multiple parts. It's good for the review too, because then you have comparison so that you can tell what the difference is between the answers. But for the actual test, I can just make up a new statement every single time. So there won't be any chance of mixing them up like that. So I left a couple there for you to do. There's some more on the review. But the answer's there. I'll let you online, so I'll let you try a couple, triple them without me. I'll try to leave some of this one open as left for you to do too. Number 4 here, it has given a for all statement. Comma, x even, or x divides 18. Implies x plus 1 is odd, and x squared is greater than 3. All right, now this is one of those where they say, You're fine. This is the one where they say find the counterexample for it. But I make you do the negation as a step in the process. You could find the counterexample by looking at it the way it is. You just have to remember that you're supposed to find something that makes the first half true and the second half false. But once you got the negation written down, it makes it a little bit easier to see. So first negate. Then you say there exists x element of z such that negate everything else. So negating an implication means you keep the first half, x is even, or x divides 18. change that to and negate this. So the Morgan's on this, I'll say x plus 1 is even, or x squared less than or equal to 3. Yeah, you can use the other version of even if you want, like 2 divides x. That'd be okay. Yeah.
What's the Z symbol again?
Oh, it's integers.
Okay.
So positive or negative whole numbers, or 0. So you got to use whole numbers for these if you're looking for a counterexample. There's probably a bunch of counterexamples on this one. So a counterexample for the original, again, it means an example of the negation. So I do want a whole number or positive or negative integer such that either it's even or it divides 18. So then we can use even numbers or things like 3, 6, well that's even too. 9 times 2 is 18. And then the other thing is true, and both things have to be true. Either one of those and either one of these. Smaller than or equal to 3 when you square it, or just that x plus 1 is even, which is kind of easier. So I think x equals 3 probably would work. Because 3 divides 18, and 3 plus 1 is even. So I get that. 3 divides 18, because 3 times 6 is 18. So that's true. And x plus 1 is even. 3 plus 1 is even. Of course, it's 4. So, true and true gives me what I want. But there's a lot more, I think. Like negative would work too. X equal to negative 3. That does the same thing. Negative 3 goes into 18 also, is times negative 6. Or, and negative 3 plus 1 is negative 2, that's even. So that works as well. I think there's a bunch more though. Let's see what I put. Oh, I didn't even put negative 3 on here. There's I mentioned x equals 9 works. X equals 0 works. There's lots of possibilities. So I'm glad I mentioned negative 3 since it's not even in one of the answers I put on the key. This one's like too easy to find a counterexample almost. There's so many possibilities. But as long as you make sure you get true and true, you'll have a counterexample that works. Oh, I ended up doing the whole thing. Well, you can try to find a different counterexample if you want. Any question?
I do.
Yeah.
So will 1 work?
Let's see. Oh, 1 divides 18, so 1 goes into any number. And 1 plus 1 is even. Yep. Also, 1 squared is less than 3. It's like this, you can have stuff that works for almost everything, but all you need is 1 of each because they're both connected by ors. So you need it to be even or divide 18, or to be odd or less than or equal to 30 when you square it. So, yep. The next one is another negation, but I'll let you do that. It doesn't. The next one I didn't ask for a counterexample, just negate it, so you can try it and check your work. And then there's the sentence ones. I did a couple of those already, but I think I can do another 1 or 2, maybe. that's not on here for variety. So it's the one about the pi. It says, the given statement is if you have a French apple pie, I'm going to abbreviate this, then you have the ingredients, raisins, cherries, and glazed cress. Okay, so I didn't have to write it all out. So it has things like find the contrapositive, of original. So that would just say, and I think I'll be specific just to help you out. I didn't even say it on here, but I'll say it on the test. I'll say use if then again, since that would be helpful. Then just switch the order, but also negate. So if you don't have I gotta make this shorter so you don't have to write an essay. It'll be a short ingredients list for the test if it's ingredients or something like that. Remember the one from the quiz? You should look at that one again too. It was one where if you have, no, I think on the notes I did the one where if you have water, then you're guaranteed to have hydrogen and oxygen. Now on the quiz was the one that if you have temperature and pressure, then the water boils. But this one, so if you don't have those ingredients, then you don't have French apple pie. Which opinions might be different on that. There's a lot of recipes out there, right? But I think you need all that stuff for real French apple pie. Let's see. So here's a different one, and I'll leave the other ones on there for you to try. Here's the write the converse using the word necessary. Okay, this one that was tricky because of the fact that it switches the order like twice in a way. So let me review what the converse looks like. So if you have the original, if you have P, so the original is just P implies Q, and the converse is just switching the order. Q implies P. But then if you change it to use the word necessary, then the original is Q is necessary for P. So now the converse using the word necessary is P is necessary for Q. Kind of helps to do it like that, like a small chart. You can see that it doesn't matter which way you go. Like you go along the top and say, okay, here's how you write the original, and then just switch P and Q to go down, and you get the converse using the word necessary. Or you can make the converse first, Q implies P, and then put it into the necessary format. I think, I don't know, going along the top and then down seems like it makes it is a little easier than down and then right. But they both come to the same place. Doesn't matter how you think about it, you get that. P is necessary for Q. So this is the one that, since it's the converse, it should turn out not to be necessarily true compared to the original. So if I write the sentence, it would be that having a French apple pie is necessary for having the ingredients list. Because B was the first one. But that isn't raisins, cherries, and glazed crust. It isn't really, assuming the original is true, the converse isn't really true. Because there's other ways to get the ingredients. You could just have a cupboard with all the ingredients in it. You don't have to have the actual pie there. It's the same as the one with the bicycle. In that case, it would be, the converse would be having a bicycle is necessary for having two wheels. But there's other ways to get a couple of wheels. So. I don't know how much time we have. Oh, about 10 minutes, okay. Maybe I should go look at a couple from the quizzes. Did anybody have any questions that you were wanting to ask? Yeah.
Will there be any questions related to circuits?
Yes, right. There aren't any circuits on the review here, but they are on the quizzes. So let me look at those. Yeah. Like in quiz 3, there are circuits. So definitely review those circuits there. Those are all the gates that you need to know how to do. Most of them are the same as what's on the truth table, but there's a couple that you only see on the truth table, and there's a couple that you only see on the circuits, usually just from historically or something. Like, there's not really, we never use a circuit for implies. And I don't usually put XOR on the truth table, and I don't usually put the adders on the truth table because they have 2 outputs. So here's an example circuit, quiz 3. So yeah, P, Q, R, T. I know you have to know half adders, so we'll review that. And half adder, I'll always label that there's a sum and a carry. And I know to put XOR in there. And this one isn't the same as the one on 3B, but just for time's sake, I just put a full adder on it now. And the sum and the carry. So the best thing I'll do for these, I think, is like the last question on quiz 3. I'll give you the inputs for B, Q, R, and T. So let's say given let's just do with them all equal to 1. P equals 1. Q equals 1. R equals 1. T equals 1. We could do it with another input set too. So, but I'll do each one. I'll only have you do 1 input set on there. So if you just want to write right on the picture, I'll have the picture on the test. You can just do that, and then I'll do a separate question for the next one. So second picture. So you put 1, 1, 1, 1 here. So half adder and full adder are not too hard to remember. because it is just addition, right? So they both do the same exact thing, they add, and they put out a sum and a carry. The only difference is that the full adder can add 3 numbers. So you have to remember that the carry is the 2's place though. So when I add 1 plus 1 here, I get, let's put under here, 1 plus 1 equals 2. But 2 is equal to a 0 sum and 1 carry. Is binary. That's the trickiest one to remember. When you get 3, it's pretty easy because they're both 1. But if you get 2 as your output, that means the sum is 0 and the carry is 1, because that's the 2's place, is the carry. So XOR, if they were both 1, XOR comes out 0. You have to remember it's exclusive OR. But if one of them is 0 and one is a 1 going in, like here, then it works like regular OR and spits out a 1. And then I put in another 1 here. So now the full adder is getting 1, 1, 1. So that gives me 3, but you could write inside if you want. All right, so 3, though, that means you get a carry of 1 and a sum of 1, because it's the binary for 3. So that means the answer is 1, 1 for this one. That pretty much covers it pretty well. It's a pretty good example because it has almost everything in there that you need to know. But also notice that you have to have like you do need to know what and or do and not. They just work the same way as on truth tables though. You think of 1 as true and 0 as false. So here's another one. You can make these up yourself too, but for the to check your answer, do the ones that are on the quiz again, but check versus the answer that I gave out. And then there's also ones in the notes you can check. You can do again, check your answer. And there's ones in the book questions. So it's not too hard to make your own, but you want to be able to check to make sure you're doing it right. I think it's pretty straightforward. So, like you're given a regular OR, and then an XOR, and so these are the given values here, 1, 0, 1, and then maybe an AND. Oh, AND has a different shape, doesn't it? Okay, I'll change that up. Let's do it not. Just for fun. And big AND. Okay. So, yeah, so find this one. I guess probably on the test I'll make it look like that too. So I'll just show you what it would look like. P, Q, R, T, and I'll say, what did I go with? P equals 0, Q equals 1, R equals 1, T equals 1. Okay, so I'll put it in blue. So it was 0, 1, 1, 1. So, or either one of them or both gives you out a 1. But XOR, it also has the exclusive, so if they're both, it gives you out a 0. Then not switches it, but I brought a 1 all the way from over there. And if you have 1, 1, you get out a 1. So the answer is a 1. I think those are those will be pretty straightforward. Just don't forget that they're on there, because you do have to make sure every single question that's on the quiz makes a good test question. I'll just change the order of the circuit, of course, a little bit.
Are you always going to write in the operator into the shape?
Yeah, I don't make you remember the shape. Yeah, I put the words in them, or the initials. Yeah, good question. Any other?
Thought I should know ahead of time.
Let's see. Yeah. Oh, and so another kind of question that's on the quiz, but I didn't put one on the review, is translating hexadecimal to decimal and binary. So these you can totally practice on your own. Oh, there you go. Just make up whatever one you want and check it. Check it, do it, and then do it the long way. So if you want hexadecimal, the fast way is to break them up into groups of 4. And remember, if there's any extras out front, then you have to make that its own group of 4, but just think of it as having zeros, leading them up. So this one would be 1 plus 2 plus 4 plus 8, 15. This one would be 1 plus 4 plus 8, 13. So I'm doing like 1, 1, 0, 1 equals 8 plus 4 plus 1 equals 13. But in hexadecimal, A, B, C, D, E, F. You can do it on your fingers, but it might be a good idea to just write it down somewhere. So in hexadecimal, 13, 15 is DF. Those are nice. Those you can do any binary to hex or back just by knowing how to convert a 4-digit binary number. And I might put some small binary numbers on there that you're supposed to do to decimal as well, like the ones on the quiz. So small enough so that you can do it all by hand, though. Won't make them any bigger than that. Okay, oh, I better let you go. Any more questions, of course, you can ask me on the Teams tomorrow. I might just go on a little bit. Paul Terry here?
Yeah, I'm here.
Yeah, here's that quiz.
Thank you, sir.
It's very
Gonna
fancy,
Benson come
but
in.
it's such a small screen
Trade
too. I didn't
glass.
realize.
That's all good.
Yeah. How much storage do you have on it?
256 gigs, but I plan on upgrading it with a 1 terabyte SSD.
Oh, I just got one from home. I was using one of my PS4. Oh, not an SSD, just a regular hard drive. 1 terabyte SSD is expensive.
Yeah, but I'd like to never run out of memory ever.
Yeah, but like, what are you using an SSD for, man? Like, you need that for a rare amount of things, really. I mean, it's a luxury, is what I'm saying.
Extremely fast storage on demand whenever you want.
Have a good day.
That's not a luxury to me.